article, Categorization of Whistled Consonants by French Speakers, written by myself, Julien Meyer, and Fanny Meunier. So to introduce this topic, I would like to talk a little bit about what whistled speech is. So whistled speech is a naturally modified speech form, which is characterized by its frequency augmentation, by the whistled transposition of certain features in the modal spectrum, as well as a drastic change in the spoken timbre. What's interesting about whistled speech is that the vowels are pronounced, or the whistled vowels are pronounced very differently from the whistled consonants, and whistled vowels in non-tonal languages usually employ stable frequencies, whereas whistled consonants are characterized by the changes in these stable vowel frequencies. So in this article, we focused on whistled consonants, but there have been a number of previous articles analyzing both whistled consonants and whistled vowels. So these previous experiments have usually explored whistled consonants produced and perceived by native whistlers. We can cite Rieland in 2004, who conducted experiments with Spanish whistlers who would stand at a certain distance from each other and whistle logotomes to each other and need to recognize and reproduce these logotomes, so vowels and consonants. And then more recently, Meyer et al. In 2019, who analyzed whistled consonants with Tashlit Berber whistlers. Once again, native Tashlit Berber whistlers whistling to each other. There have also been whistled vowel perception experiments by naive speakers, so participants who would have to recognize whistled vowel productions without ever having heard or heard of necessarily whistled speech. More importantly, we can cite Meyer in 2005, who asked French speakers, native French speakers, to recognize and identify 4 whistled vowels, I, E, A, O, E, A, O in French. And more recently, Meyer et al. In 2017, who asked speakers of different language backgrounds, Spanish and Chinese speakers, to once again identify these whistled vowels to analyze how language background influences vowel perception. So what will be interesting in this article is that we proposed experiments analyzing whistled consonant perception by naive French speakers, which hasn't been done before. And throughout this article, we will be asking ourselves whether naive participants can recognize consonants, can recognize whistled consonants as they can recognize whistled vowels, demonstrated in Meyer's 2 articles, and which factors underlie participants' consonant categorization. So the stimuli we chose are based off of 4 consonants, so K, P, S, and T, which were presented in a vowel consonant vowel form as aka, appa, assa, and atta, with the first vowel and the last vowel obviously being A. So the idea of using this vowel consonant vowel form was to really allow participants to focus on the consonant, which really is characterized by a change in that stable frequency proposed by the whistled vowel form. So I'd like you to hear an example of these 4 whistled consonants, so the aka, appa, assa, atta, so you can have an idea of what this whistled consonant speech sounds like. So that gives you an idea of how the consonants really are characterized by the change in that initial and final frequency. We also chose these consonants because they are representative of different consonant groups, not only in linguistics, where P is bilabial, T is dental alveolar, K is velar, and S is fricative, but also because in previous whistled speech analyses, K, P, S, and T are often in different consonant groups. So we can cite Rieland, who conducted the experiments with the Spanish whistlers in 2004, who proposed 8 consonant groups based off of consonant and whistled speech perception, and opposed K and P to S and T in 2 out of those 8 consonant groups. We have Trujillo, who proposed 4 consonant groups based off of the manner of whistling rather than the perception of these whistled consonants, and who once again opposes K and P to S and T. And then finally, we can focus on the Yo-Silbo Association consonant groups, Yosilbo being an association based in the Canary Islands, which focuses on teaching whistled speech to children or to interested adults, and whose consonant groups focus on the manner of whistling, since they're trying to teach whistled speech. And they oppose K to P and to S and T. So these four consonants, are in 3 different groups out of the 5 consonant groups that they use in total. However, despite these differences in consonant groups proposed here, usually this research agrees on certain consonant oppositions, which include high and low loci, and continuous and non-continuous. So high and low loci oppose K and P to S and T. And you can really see that in this diagram where S and T have a frequential rise here in the center part of the segment, which is the consonant itself. So the S goes up in frequency, and so does the T. Whereas K and P don't show this frequential rise. So high loci S and T, and low loci K and P. And also the difference between continuous and non-continuous, which is S versus K, P, and T. You can see that S doesn't have a clear stop between the two vowels. It's really relatively continuous. There's no silence, whereas in K, P, and T, you can really see that clear blank space of silence. So there are other potential distinctive elements between these consonants, which include glottal occlusion and the clarity of stop, which you can also kind of see in this diagram. But we aren't sure of how these other distinctive elements will influence perception, so we chose these consonants to be able to focus on different components of the consonant groups. We conducted 2 experiments that were constructed using the same structure. Participants would hear recording and were to indicate whether they heard S, T, K, and P using the computer keyboard, which on the screen they would see this diagram, and the consonants were attributed to the arrow keys, as you can see with the arrows. Both experiments followed the same 3-part structure, which consisted of an initial consonant perception test based off of 4 recordings, so one recording for each consonant, and each of these recordings was heard 10 times, so a total of 40 stimuli for this initial consonant perception test. Then there was a training portion which used these same recordings, so 1 recording per consonant, and each of these recordings was heard 4 times for a total of 16 stimuli. During this training portion, participants would receive feedback, so when they responded whatever consonant they thought it was according to the stimuli, they would receive either, oh, correct answer, this was the correct answer, or that was the wrong answer, without being given what the correct answer was if they had chosen wrongly. Finally, there was a consonant perception test in the 3rd part based off of 16 different recordings. So 4 recordings, 4 versions of each consonant, and these 4 versions were heard 3 times each for a total of 48 stimuli. So a lot more variation in this 3rd part than in this 1st part, where we only had one recording, 1 version of each consonant. The participants, as I mentioned before, were French-speaking, naive listeners with no hearing or language impairments. In our first experiment, we used natural whistled consonant recordings. So these natural whistled consonants usually are ranged between 1,142 hertz and 2,629 hertz, with an average frequency of 1,715 or 16 hertz. But when you recall the consonant shapes, this average frequency isn't necessarily representative of the consonant movement. So this is just to give you an idea of how high these whistled consonants are. The participants were 20 adults, 15 females, with an average age of 29 years. When analyzing the results of experiment 1, we used the results from parts 1 and parts 3, for which we found 51% of correct responses obtained, which is well over chance at 25%. We applied a global repeated measures ANOVA, which showed a main effect of consonant type. We then applied a post hoc test with the Bonferroni correction, where we found that P was different from T and K. P was different from T, and that K tended to be different from T and S. So using these post hoc results, we can establish the following hierarchy, which is that S was recognized as well as T and better than K and P, which we can see in this diagram that overall S and T were better recognized than K and P. However, the results between part 1 and part 3, part 1 in blue and part 3 in orange, are relatively different. And in fact, in part 1, we find that 46.5% of correct responses were obtained, and that using a post hoc test, S was only significantly different from P, which means that there are two possible hierarchies. Either S is better recognized than T, K, and P, or S is recognized as well as T and K and better than P. So we can see these two possibilities. However, in part 3, where 55% of correct answers were obtained, the post hoc test shows that P is different from S, that P is different from K, and that K is different from T, which underlines the same hierarchy we found overall. In experiment 2, we used whistle consonant recordings that were lowered using a phase vocoder. So these recordings, the same recordings from experiment 1, were lowered to a frequency below 600 hertz. So the range then became, the lowest frequency was 228 hertz and the maximum 525 with an average of 343 hertz, which is a lot lower than the whistled consonants in the first experiment. There were 16 participants for experiment 2, 9 females, and the average age was 24.4 years old. Once again, we analyzed parts 1 and parts 3, for which we found 41.5% of correct responses obtained, once again over chance. And we applied a global repeated measures ANOVA, which showed the effects of part and of consonant type. So this time we could really compare the results from each part. And we found that in part 1, 32.7% of correct responses were obtained, and in part 2, 45% were obtained. This is very easy to see in the diagram, where each of the consonant responses increased. For each consonant, participants obtained more correct answers in part 3 than part 1. So that's this increase in number of correct responses or percentage of correct responses is very clear in this diagram. Using the post hoc tests, we found that S was different from K, P, and T, which allows us to establish a different hierarchy than in experiment 1, which is that S was better recognized than T, K, and P, which were recognized approximately the same. And this really shows the dominance of S compared to the other consonants, which wasn't necessarily the case in experiment 1. When comparing the two experiments using a global ANOVA with experiment as a between subject factor, we found that there was a main effect of consonant type, and the interactions part and experiment and consonant and experiment were significant. In addition, these differences can be attributed to the differences in results for K and T, which you can really see in these diagrams. This is the natural whistle consonants, where K was recognized much better. And this is lowered consonants. Once again, there's a big difference between the K results. And same thing for T in these two experiments. So in conclusion, naive listeners can categorize these whistle consonants better than chance being 25%. However, lower consonants were harder to recognize, and participants only had 41.5% of correct responses compared to 51% that they obtained with the natural frequency of whistle consonants. In addition, in experiment 1, results were consistent between parts 1 and 3. And in experiment 2, the results improved. This seems to indicate that participants created a model of each consonant, which could then be applied to that third part, which had a number of different recordings, so more variations in the pronunciation of the consonants, which is an interesting result. In addition, we found a predilection for consonants with rising loci, so S and T, though we found that in experiment 1, T and K were better recognized than they were in experiment 2, which seems to suggest that the stops could be more important in consonant perception than they seem to be initially. And maybe these stops could be the key differences between recognizing lowered whistled consonants and normal whistled consonants.